Hey time traveler. Okay, I just wanted to talk on like one small little thing. And I say it's small because hopefully it's gonna be a short video. But it's a really important concept, so I just wanted to give it its own video. And that's relative motion. You'll see this a lot in physics problems that are trying to trip you up by making them seem more complicated than they are. Okay, so you can see from my little diagram that we have a man golfing on a train. I don't know, maybe it's one of those country club things. And the train is moving at 30 meters per second, and then he is golfing it into a hole, and it falls into the hole after 2 seconds. The ball technically is going at 28 meters per second in the x-hat direction, but this is where I was always told it's like defining your system. If you define this whole thing as your system, this ball is going at 28 meters per second in the x-hat direction. But if you define this as your system, you are saying that the man, you're saying that he has a velocity of 0. And everything is relative to him. And then this ball would land and would have a velocity of 2 meters per second in the negative x-hat direction. Sorry, that looks a little wrong. Let me give him a club. And while this might not look really important now, once you start talking about carts and pulleys and stuff, this becomes really, really, really important because you are going to be asked to define your system. Let me give like a little example. I'm gonna try and not use anything that's like requires like equations that we don't know yet. Let's take the example of 2 cars. This car is going faster and hits the back of this car. Oh no. They can be cross. You can say that this car is going at 30 meters per second, and this car, 28 meters per second, and this car was going at 30 meters per second. If you were asked how fast did this car crash into this car, you can't really say that it was going at 30 meters per second, but relative to this car, it was going at 2 meters per second. So the car might have been fine, actually. This is why if you're ever on the road and you're looking like at the car next to you, relative to you, they're not going anywhere. But both of you are moving at 70 meters per second. That's why head-on collisions are so much worse, because you are going at, if I'm going at 60 and they're going at 60, relative to each other, we are going at 120 miles per hour. Versus on the highway, we're going at the same, like, velocity direction. Velocity direction-wise, you are going 0 towards each other. Or like, relatively, your velocities are 0. Hopefully that kind of makes sense. And I like to use the cars example because I think it's just like a really common example that we all see. Okay. Hopefully this makes sense. You'll kind of like know in more obvious cases when a system should be defined relative to something inside of it. But there are less obvious things, and that's like a brain teaser for like another day. So hopefully this helps. Let me know if anyone has any questions. Good luck, time traveler. You got this.